Hello everyone, myself Bhuvnesh Kumawat. I will be covering modern algebra in this series of lectures. Today we will start from group theory. So first we will see our syllabus for UPSC CSE. This is syllabus for UPSC CSE. Okay, so we are going to cover groups, subgroups, cyclic groups, cosets, Lagrange's theorem, normal subgroups, quotient groups, homomorphism, isomorphism, okay, then permutation group, rings, subrings, ideals, homomorphism, integral domain, ideals, okay, then field, subfield, quotient field, etc. We are going to cover in this series of lecture. So now we will start from basics. So first we will define sets. So sets क्या होता है? Set is a collection of elements or things. This is a mathematical model. For example, if you take set of real number, okay, if we take minus infinity, minus 2, minus 1, 0, 1, 2, going up to infinity. This is set of real numbers. So this is set. Now binary ऑपरेशन. बाइनरी ऑपरेशन क्या होता है? अगर हम सेट के दो एलिमेंट्स को लेते हैं और उसमें कोई भी ऑपरेशन डिफाइन करके उसको ऑपरेट करते हैं तो बाइनरी ऑपरेशन होता है. जो आउटकम होता है वो उसी सेट का पार्ट होता है. फॉर एग्जांपल, if we take two elements from real number, suppose we take 3 and 5 that belongs to real number R, and we define a binary operation A star B equal to mod A minus B. Okay, so this is minus is a binary operation with modulus. So this will be 3 minus 5, that is 2. That also belongs to real number. So this is binary operation. This is defined as binary operation. And we denote this binary operation with this star. Okay, so this is binary operation. Now this whole mathematical structure is the algebraic structure. This whole structure is algebraic structure. So a algebraic structure is a non-empty set G occupied with one or more binary operations is called algebraic structure. For example, we can take a set of natural number with binary operation addition. So this is a binary structure. Similarly, we can take a set of rational number with binary operation subtraction. Okay, so this is whole a algebraic structure. Similarly, a set of real number with binary operation as modular, as addition. So now we will classify a set into quasi group, semi group, monoid, and group. Okay. So first we will define four basic properties. So first property is closure. So we will write like first property closure. Closure means if A and B belongs to some set F, then that implies A binary operation B should also belongs to same set S. So then we will call it closure. मतलब किसी सेट के दो एलिमेंट ए और बी को हम ऑपरेट करते हैं तो ऑपरेशन के बाद जो आउटकम आता है वो भी अगर उसी सेट में बिलोंग करता है तो वो क्लोजर प्रॉपर्टी सेटिस्फाई करेगा. सेकंड इज एसोसिएटिविटी. Associativity. That means if A, B, and C belongs to some set S, then A star B star C should be equal to A star B star C. मतलब क्लब हम दो किसी भी दो एलिमेंट क्लब करके तीसरे के साथ ऑपरेट करते हैं तो वो बाकी बचे हुए दो एलिमेंट को थर्ड साथ ऑपरेट करने के बराबर होगा. So this is associativity. Now third property is identity element. Identity element means if A and B belongs to some set S, then A star B should be equal to A. So here we will call this B as identity element. Here, here B is equal to E. हम आइडेंटिटी एलिमेंट को ई से डिनोट करते हैं। तो यहाँ पे जो बी है वो आइडेंटिटी एलिमेंट है, क्योंकि अगर हम किसी सेट के किसी एलिमेंट ए को बी से ऑपरेट करते हैं तो सेम वही एलिमेंट हमें प्राप्त होता है। तो मतलब ये बी आइडेंटिटी एलिमेंट है। ओके, फोर्थ प्रॉपर्टी इज इनवर्स। इनवर्स इनवर्स मीन इफ ए एंड बी belongs to some set S, then A star B should be equal to identity element E। मतलब A को हम B से ऑपरेट करते हैं तो हमें आइडेंटिटी एलिमेंट मिलता है, तो ये B यहाँ पे इनवर्स होगा, इस एलिमेंट A का इनवर्स होगा। तो here B is inverse of element A। Okay, so this is fourth property. Now fifth, we will define fifth property also, commutative. Commutative means if A, B belong to some set S, then A binary operation B should be equal to B binary operation A. So we will call it commutative. Okay, so these four properties we will use to classify a set into quasi group, semi group, monoid, and group, then abelian group. So first is quasi group. Quasi group, here quasi group. First is quasi group. When closure property is satisfied, closure property is satisfied in a set, then we will call it quasi group. Okay. Then second is semi group. When closure property plus associativity is satisfied in a set, then we call it semi group. And third is monoid. If closure and associativity and identity element, these three properties these three properties are satisfied in a set, then we will call it monoid. Now fourth is group. When all four properties, that is closure, associativity, identity element, and inverse, these four properties are satisfied in a set, then we will call it group. Okay. For example, two element, if we take two element A and B that belong to some set G, and we define a binary operation as small o, then A binary operation B should belongs to G, that is closure property, and this is associativity. Third is identity element. When we operate A with identity element, we will get same element A. अगर हम आइडेंटिटी एलिमेंट को किसी एलिमेंट ए से ऑपरेट करते हैं तो सेम वही एलिमेंट ए प्राप्त होता है, तो हम उसे आइडेंटिटी एलिमेंट कहेंगे। Here, this E is right identity and this E is left identity. And later we will prove that left identity should be equal to right identity. Now, fourth one is inverse. Suppose if we take A belongs to Z and B belongs to same group Z, then A binary operation B should be equal to B binary operation A should be equal to identity element. Then this B is the inverse element of that group. Now we will define abelian group. If all five properties are satisfied in a set, then we will call it abelian group. Or if a group satisfies commutative property, then we will call it abelian group. So a commutative group is called abelian group. So abelian group is a closure plus associativity plus identity element plus inverse. then plus commutative. All five properties are satisfied in a set, then we will call it abelian group. Now we will define modulo operation here. तो मॉडुलो ऑपरेशन क्या होता है? मॉडुलो ऑपरेशन दो तरह के होते हैं. फर्स्ट इज एडिशनल मॉडुलो एन. मतलब if we if we take two elements A and B that belongs to some group G, then uh, A modulo operation and B should be equal to remainder of A plus B divided by N. So A और B को हम ऐड करने के बाद उसको N से डिवाइड करते हैं, तो जो रिमाइंडर आता है वो A मोडुलो मोडुलो M B के इक्वल होगा. ओके, तो दिस इज additional modulo operation. This is additional modulo M operation. And second is the multiplicative modulo M operation. If A and B belongs to some group G, then A multiplicative modulo M B is equal to remainder of A multiplied by B divided by N. अगर हम दो एलिमेंट लेते हैं किसी सेट के ए एंड बी, उस पे मल्टीप्लिकेटिव मॉडुलो एम ऑपरेशन करते हैं, तो वो इक्वल होगा ए मल्टीप्लाइड बाय बी डिवाइडेड बाय एन का जो रिमाइंडर रहेगा के बराबर होगा. ओके, तो दिस इज मल्टीप्लिकेटिव मॉडुलो एम ऑपरेशन. इन कॉन्ग्रुएंस, if we take A congruent to B mod n, we take this operation, then we can say third is congruence. If A congruent B mod n is equal to remainder of A minus B divided by n. Okay, should be equal. It should be equal to 0. Okay, means we can say remainder of A by n should be equal to remainder of A by n should be equal to remainder of B by n. Then we will call it A congruent B modulo n. Now we will take few theorems of groups. First is, these are basic theorems. These are fundamental theorems of group theory. First is, in a group, identity element is a unique. So we will prove it. Suppose we take two identity elements E1 and E2 belongs to some set, some group G, are two identity element of G, group C. अगर हम ग्रुप जी के दो एलिमेंट लेते हैं E1 E2 जो आइडेंटिटी एलिमेंट है, सपोज दीज आर टू डिफरेंट आइडेंटिटी एलिमेंट, देन by identity property we can say E1 dot E2 should be equal to E1 when we take E2 as an identity element. अगर हम E2 को आइडेंटिटी एलिमेंट लेंगे तो E1 dot E2 should be equal to E1. Similarly, we can take E1 dot E2 should be equal to E2 if we take E2 as identity element. ओके, अगर हम E2 को E1 को आइडेंटिटी एलिमेंट लेंगे तो ये E2 के इक्वल होगा. तो कॉल इट दिस इक्वेशन 1, दिस इक्वेशन 2. फ्रॉम 1 and 2 we can say E1 equal to E2. So our assumption was wrong. Earlier we assumed that E1 and E2 are two different identity elements, but they are similar, same. Second theorem is, in a group, inverse of any element is a unique. Okay, तो किसी भी ग्रुप में जो इन्वर्स होता है किसी भी एक एलिमेंट का वो यूनिक होता है, बट हर एक एलिमेंट का इन्वर्स डिफरेंट होगा. सो वी विल प्रूव इट. सपोज वी टेक ए बी एंड सी बिलोंग्स टू सम ग्रुप जी. अगर हम ए बी सी तीन एलिमेंट लेते हैं किसी ग्रुप जी के, वेयर B and C are inverse element, inverse elements of element, inverse element of A। ओके, अगर ए और बी, बी एंड सी किसी एलिमेंट ए के दो अलग अलग इनवर्स है, देन वी कैन राइट ए बाइनरी ऑपरेशन बी should be equal to identity element E should be equal to B, or we can take this as multiplicative operation। ओके, तो अगर ए और बी को हम ऑपरेट करते हैं, ए डॉट बी शुड बी इक्वल टू बी डॉट ए शुड बी इक्वल टू आइडेंटिटी एलिमेंट, call it equation 1। Then similarly we can write A dot C should be equal to identity element should be equal to C dot A by identity property of a group। Now from 1 we can multiply this first equation by C or by C। Okay, if we first multiply this first equation by C, we can multiply because if A and B are two elements of a group, then A dot B should belong to same group G by closure property। Now, if A or B is an element of a group G, then and C is also element of group G, then we can multiply AB and C by closure property. AB dot C should also belong to same group G। Okay, so after multiplication, we will get A dot B should be equal to A dot B dot C should be equal to E dot C should be equal to B dot A dot C. Call it equation 3. Now we can put value of AC, value of AC here, value of AC from this equation 2. From equation 2 and 3, we can write A B dot C is equal to E dot C is a C equal to, and we can put AC value from here. AC is equal to E, so B dot E, and by these two we can write C is equal to B। So hence proof, we assume that B and C are two different inverse of element A, but in end we have proved that B is equal to C। So here in inverse element of A is unique। Now third property, third theorem, if let G be a group for A and B, A B inverse should be equal to B inverse A, that we have to prove। So suppose if A and B belongs to some group G that is given in our statement, then we can say A dot B, okay, A dot B will also belong to some same group G by closure property, or we can say A B inverse will also belong to same set G or same group G by inverse theorem। Okay, so now take AB and from this from this we can say if A and B belongs to some group G, that means A inverse and B inverse will also belong to same set G। ठीक है, अगर ए और बी किसी सेट में है तो ए का इनवर्स और बी का इनवर्स भी उसी सेट में होगा बाय इनवर्स प्रॉपर्टी। और वी कैन से बी इनवर्स ए इनवर्स will also belong to same group G by closure property। Okay, So we will use this and we will use this. So AB is an element of group G and B inverse A inverse. Okay, we operate these two elements, that is equal to A, B, B inverse, A inverse. Here we can club B and B inverse by associativity. Okay, because associativity is satisfied in a group, so we can club it. Now that is equal to A identity element A inverse. By identity property, we can write like this. Now we can write A inverse, that is equal to E. E is belong to E is identity element of group. E is belong to Z. Hence, here we are operating two element of a group G. हम अगर किसी ग्रुप के G के दो एलिमेंट ए बी एंड सेकेंड एलिमेंट बी इनवर्स ए इनवर्स, अगर इन दो एलिमेंट को ऑपरेट करते हैं तो हमें आइडेंटिटी एलिमेंट मिल रहा है. इसका मतलब ये जो एलिमेंट है, ये जो एलिमेंट है वो इस एलिमेंट का इनवर्स है. रिमेंबर दैट वी हैव प्रूव दैट A star B is equal to E, matlab B is an inverse element. Okay. Here B is the inverse element of A. Similarly, this B inverse, this B inverse, A inverse is the inverse element of AB. So we can say AB का inverse element होगा B inverse A inverse. Okay, hence proof. Now, fourth theorem. If cancellation law hold in a group, one statement, or we can say let G be a group, then ABC belongs to G, then AB equal to AC means B equal to C. That is called left cancellation law. Similarly, this is right cancellation law. So we can prove this if A, B, C belongs to some group G, okay, then and and given that AB equal to AC. Now we can pre-multiply this equation 1, we can pre-multiply this equation 1 by A inverse, because if these three are element of group subgroup G, then A inverse should also belong to same group G. And by closure property, we can write this A inverse AB equal to A inverse AC, or we can write A inverse A by associativity. We can write like this A inverse A dot C. That means B is equal to C. So this is left cancellation law. Similarly, we can prove right cancellation law. Now we will take few examples of group. So suppose if we have a group G such that group G is equal to X such that X equal to 2 raised to power A, 3 raised to power B, where A and B belongs to some set of integers Z. So we have to check for basic property, and here the operation is given multiplication. Okay, so this is group with multiplication binary operation. Now we have to check for basic property G1, that is closure. If we take two element like x1 equal to 2 raised to power a1, 3 raised to power b1, then x2 equal to 2 raised to power a2, 3 raised to power b2, and x3 is equal to 2 raised to power a3, 3 raised to power b3. Now, for closure property G1, we can check x1 dot x2. That means 2 raised to power, here base are same, here 2 is the base, तो पावर ऐड हो जाएगी a1 प्लस a2, और यहाँ पे तीन बेस सेम है तो पावर ऐड हो जाएगी जब हम इन दो को मल्टीप्लाई करेंगे. देन b1 प्लस b2, और किसी भी दो इंटीजर का सम इंटीजर ही होता है, बिकॉज ए एंड बी बिलोंग टू सेट ऑफ इंटीजर जेड। सो इन दोनों का जो समेशन है वो भी सेम सेट ऑफ इंटीजर को बिलोंग करेगा। So this is also integer, this is also integer. That means this belong to same set of G. This closure property is satisfied. Similarly, we can check associativity. X1 dot x2 dot x3 is equal to x1 dot x2 dot x3. We can check this to that, क्योंकि ये इक्वल होगा 2 raised to power a1 प्लस a2 प्लस a3। हमें पता है कि एडिशन में एसोसिएटिव सेटिस्फाइड होती है कि ऐड आप चाहे तो दो को क्लब करके तीसरे को ऐड करो, या पहले दो को ऐड करके तीसरे का ऐड करो तो सेम ही होगा। ओके, so that is equal to 3 raised to power b1 plus b2 plus b3। Now third property, G3, we have to check identity element, and we know in multiplication operation identity element is a 1। Okay, so take a equal to 0 and b equal to 0, that means x e, that is identity element, will be equal to 2 raised to power 0, 3 raised to power 0, because 0 belongs to integer. So this is also belongs to same set, that is equal to 1 belongs to group G. And now fourth property, inverse. For inverse, take a2 equal to minus a1 and b2 equal to minus b1. So we can say that x1 dot x2, that is 2 raised to power a1 plus a2 raised to power b1 plus b2, and that will be equal to 2 raised to power 0 if a2 is equal to minus a1 and b2 is equal to minus b1। मतलब ये दोनों ऐड करने पे जीरो आ जाएगा, 3 raised to power 0 that is equal to 1, that is identity element xc। So this is inverse element। Okay, so here is the inverse element of x1। x1 का inverse element है 2 raised to power minus a1 raised to power minus b1। So all four properties are satisfied in this group, so we can call it group। Now, second example, similarly we can check this also. Here the binary operation is defined a plus b plus 2। So g1, g2 you can check, g1 is closer, कैसे भी मतलब इसको ऐड करो, ये इंटीजर में आना है। ओके, वी हमने जो सेट लिया है वो इंटीजर का सेट लिया है, सेट ऑफ इंटीजर। तो वेयर ए एंड बी आर इंटीजर, सो किसी भी इंटीजर को ऐड करो इंटीजर आएगा, उसमें दो को ऐड करो तब भी वो इंटीजर रहेगा, तो क्लोजर प्रॉपर्टी इज सेटिस्फाइड। एसोसिएटिव ए बी को कैसे भी ऐड करो, ए प्लस बी प्लस 2, ठीक है, तीन एलिमेंट्स लेके इसको कैसे भी ऐड करो, एडिशन हमेशा इंटीजर ही होगा, तो वो इक्वल भी होगा, एडिशन इज ऑलवेज एसोसिएटिव। ओके, नाउ थर्ड प्रॉपर्टी इज G3। Okay, so G3 inverse identity element, so we will check identity element here, A star B। Okay, so we will operate identity for identity element, A star B should be equal to A। So here B is the identity element, so A plus B plus 2 is equal to A, or by left cancellation law we can write b plus 2 equal to 0, or by right cancellation law we can write b is equal to minus 2। So here minus 2 is the identity element, minus 2 belongs to Z, because here given set is Z, so identity element is also lies in same set G। Now G4 is inverse element. For inverse element, A star B should be equal to identity element, that is minus 2। that is -2. Okay, so a plus b plus 2 is equal to -2, or by left cancellation we can write b is equal to -2 -2 minus a, or -4 minus a. Here 4 is integer, 2 is integer. Addition of these two integer will be also integer. So this belongs to Z. So here is the identity. Here is the inverse element is also belongs to same set Z. So all four properties are satisfied in this set. So we can call this set as group. Now next example, show that fourth root of unity from an abelian group with respect to multiplication. So first we will find all four root of unity. Okay. So suppose x is equal to 1 raised to power 1 by 4. Okay. We can write that can be equal to cos 2 n pi plus iota sin 2 n pi. We can write raised to power 1 by 4. 1 by 4. Or by Euler equation, okay, we can write iota 2 n pi by 4. We can write, or that is equal to cos 2 n pi by 4 plus iota sin 2 n pi by 4. Okay, so we can write like this. Okay, now take n equal to 0, then x1 is equal to 1. Put n equal to 0, cos 0 is 1, sin 0 is 0, so that is 1. Then n equal to 1, put 1 here, then cos pi by 2 is 0, and sin pi by 2 is 1, so that is equal to x is equal to iota. Similarly, n equal to 2, x is equal to -1, and n equal to 3, x2, x3, x4. x4 is equal to minus iota. Okay, these are our four root of unity. So we will prepare table, composition table with operation multiplication. As the given operation is multiplication. Okay, so we have to prove that this set is abelian group. So we will write all four root of unity: 1 iota, -1 iota. Okay, 1 iota, -1 minus iota. तो इस पहले कॉलम में और पहले रो के अंदर हम ये लिख लेंगे. अब हम एक एक जो एलिमेंट है दोनों रो कॉलम को ऑपरेट करेंगे सिंपल मैट्रिक्स फॉर्म में. तो here 1 multiplied by 1 is equal to 1. 1 multiplied by iota, iota. 1 multiplied by -1, -1. That is iota. Now iota multiplied by 1, iota. Iota multiplied by iota, -1. That is minus iota. 1. Iota, iota, -1. Okay. Iota multiplied by iota, -1. And iota, iota, -1. Sorry. This is minus iota. So here is minus iota. So here minus iota, iota, plus. Okay. So to remove this sign from here, we can remove. Okay. So now -1, -1, -1, then minus iota, +1, and plus iota. Now minus iota operates, then minus iota, +1, plus iota, -1. Okay. Now check this table. all element of this 4 by 4 matrix. This 4 by 4 matrix, you can check इस 4 by 4 मैट्रिक्स के सभी एलिमेंट इसी ग्रुप से आ रहे हैं। जो हमने सेट लिया है 1 आयोटा -1 -आयोटा, ये हमने जो सेट लिया है G = 1 आयोटा -1 -आयोटा, इसी सेट से आ रहा है, तो ये क्लोजर प्रॉपर्टी सेटिस्फाई होती है। सिमिलरली वी कैन चेक एसोसिएटिविटी। अभी हमने दो दो का ऑपरेशन किया, तीसरे एक एलिमेंट को और लेके इसी ग्रुप से वी कैन चेक। ओके, इस ग्रुप के 3 एलिमेंट को लेके हम चेक कर सकते हैं कि इस ग्रुप से 3 एलिमेंट ग्रुप एसोसिएटिविटी हम चेक कर सकते हैं। नाउ थर्ड इज आइडेंटिटी एलिमेंट। फॉर आइडेंटिटी एलिमेंट we have to check two similar rows or column. Check these two rows are similar. So E = 1 is an identity element. This is identity element. Okay. Now circle identity element in each row. These are identity element 1, 1. So we can say that 1 has an inverse as 1. एक का इनवर्स एक है। सिमिलरली आयोटा का इनवर्स -आयोटा है। -1 का इनवर्स -1 है और -आयोटा का इनवर्स आयोटा है। ठीक है, तो सभी चारों एलिमेंट का इनवर्स उसी ग्रुप के अंदर आ रहा है, तो इनवर्स प्रॉपर्टी इज सेटिस्फाइड। तो हमने चारों प्रॉपर्टी चेक की, चारों प्रॉपर्टी ग्रुप की सेटिस्फाई होती है, तो ये ग्रुप है जो गिवन सेट है 4 √of यूनिटी, वो ग्रुप है। अब हमें अबेलियन ग्रुप चेक करना है। फॉर दैट वी विल चेक सिमिलैरिटी or symmetry about this diagonal. Okay, about this diagonal which will check symmetry. So here is a 1 1 iota iota iota. So this 5 by 5 cross 5 matrix is here. We can say that commutative property is also satisfied. So this set is abelian group. Now this is last example. Okay, sorry. Next example is 0. Here the operation, given operation is additional modulo 5. So given operation is addition modulo 5, or given elements are 0 1 2 3 4. Here 0 1 2 3 4. अब दो एलिमेंट को ऑपरेट कीजिए। 0 + 0 modulo 5, that is 0 1 2 3 4. 1 + 0, remainder is 1 + 2, remainder is 3. 1 + 3, remainder is 4. 1 + 4 5, remainder is 0. Similarly, we can write remainders here 2 3 4 0 1. Similarly, 3 + 0, remainder is 3. 3 + 1, remainder is 4. 3 + 2, remainder is 0. 3 + 3, remainder is 1. 3 + 4, remainder is 2. Similarly, 4 + 0, remainder is 4. 4 + 1, remainder is 0. 4 + 2, remainder is 1. 4 + 3, remainder is 2. 4 + 4, remainder is 3. Now check this 5 by 5 matrix. This 5 by 5 matrix, all elements of this 5 by 5 matrix are from this given set G. This satisfy here. Similarly, we can check associativity. Now, in identity element, check two similar rows. Okay, this and this is similar row. So E = 0 is the identity element here. Mark identity element in each row. Okay, these are identity elements. So 0 has inverse 0. Now 1 has the inverse 4, and 2 has the inverse 3. 3 has the inverse 2, and 4 has the inverse 1. So all elements of that set uh, all element of that set has an inverse in same set. So inverse property is also satisfied. Now for abelian group, we will check symmetry about this diagonal of my. So we can say we can check 0, 0, 1, 1. So this 6 cross 6 matrix is symmetric about this diagonal. We can say this is abelian group because commutativity is satisfied in this group. Last example, here's the binary operation is given modulo 5 in multiplication, given element 1, 2, 3, 4, here 1, 2, 3, 4. So 1 multiplied by 1, remainder is 1, 1 multiplied by 2, remainder is 2, 1 multiplied by 3, remainder is 3, 1 multiplied by 4, remainder is 4. Similarly, 2 multiplied by 1, remainder is 2, 2 multiplied by 2, remainder is 3, 4. Sorry, remainder is 4. 2 multiplied by 3, 6. 6 divided 4, 8. Remainder is 3. Here, 3 multiplied by 1, remainder is 3. 3 multiplied by 6, remainder is 1. 3 multiplied by 3, 9. Remainder is 4. And 3 multiplied by 4, remainder is 2. Similarly, 4 multiplied by 1, remainder is 4. 4 multiplied by 2, 8, remainder is 3. 4 multiplied by 3, 12, remainder is 2. 4 multiplied by 4, 16, remainder is 1. अब हम मैट्रिक्स से चेक करेंगे 4 by 4 मैट्रिक्स के, तो सारे एलिमेंट उसी ग्रुप के उसी सेट के हैं जो हमें गिवन है. जी के 1 to 4 ही एलिमेंट है इस 4 by 4 मैट्रिक्स में. तो क्लोजर प्रॉपर्टी इज सेटिस्फाइड. Now we will check associative. With associative, we can check. Okay. Now we will check two similar rows. These two are similar rows. So identity element is the one. So now mark circle identity. So corresponding element is the inverse element. So one has the inverse one, and two has the inverse three. Three has the inverse two, and four has the inverse four. So all four elements of same set G has the inverse in same group, same set G. So inverse properties is satisfy होती है. Now we will check symmetry about this diagonal. Okay. So this 5 cross 5 matrix is symmetric about this diagonal. So we can say commutativity is also satisfied in this group. So we can call this group G as abelian group. So that's it for this lecture. We will cover some more properties of group in our next lecture. Thank you.